Okay, very good afternoon, children. In the last class, we had a discussion regarding what is a chemical bond and what are the factors that influence the chemical bond and how the Lewis structure will be. And now we will be entering into the topic of ionic bonding. Okay, and already I have introduced the terminology regarding the lattice energy and what are the factors that decide the lattice energy and everything. Okay, now in today's class we will be having a discussion regarding the ionic bond first of all. So generally ionic bond. So what is an ionic bond? So before entering into the bond, do you know how many types of bonds are there? Chemical bonds. Chemical bonds based upon the attractive forces. Okay. Based upon the attractive forces, chemical bonds are classified into two types. Based upon the attractive forces, the chemical bonds are classified into two types. Okay, one because of the interatomic and intermolecular bonds. Interatomic and intermolecular. Okay, interatomic and intermolecular bonds are there. So interatomic bonds, these are the strong bonds. Okay, these are the strong bonds, and these are the somewhat weak bonds when compared to the interatomic. Okay, intermolecular and interatomic. This is the major difference. And next, again these bonds, interatomic bonds, we have totally four types: ionic bond, covalent bond, coordinate covalent bond, and metallic bond. So in the starting of the bonding, I said how to identify the bonds. In the first video, in the second video, I have sent you regarding the bonds identification: electropositive element plus electronegative element, what it is. Both electropositive atoms means what it is. If it is one is both are electronegatives, then what type of bond it is. So now interatomic, under the strong bonds we have ionic bond, covalent bond, coordinate covalent bond, metallic bond. Okay. Again, under weak bonds we have two types: hydrogen bonds and van der Waals bonds. Okay, hydrogen bonds and van der Waals bonds. The students who are having the textbooks, okay, they can see in the first page itself, it is there clearly this chart. Okay, foundation textbooks are given. For them, it is given ionic bond, covalent bond, coordinate bond, metallic bond, hydrogen bond, and van der Waals bonds. Okay. Now coming to the point of ionic bond. What is an ionic bond? We will have a total depth discussion regarding the ionic bond in today's class. So what is an ionic bond? So it is nothing but it is a bond between the two ions. But one plus charge and one minus charge is there. Means what? There should be some force of attraction. Is it or not? So this plus and minus charges, already in base level you studied those as cations and anions. The force of attraction between the cation and the anion is considered as electrostatic force of attraction. So now I am defining the ionic bond as the electrostatic force of attraction between two atoms which differ in electronegativities is called as ionic bond. An ionic bond is formed between two atoms which differ much in their electronegativities. Then only the ionic bond is formed. So generally at base level, what is the base level definition means? The bond formed between the two oppositely charged ions is known as ionic bond. But at the competitive level, what is the ionic bond means? Ionic bond is resulted when there is a large difference between the two atoms in their electronegativities. Just for your sake, I am writing the definition. The oppositely charged ions, are held together by electrostatic force of attraction. Okay. The bond formed is known as ionic bond. This is the general definition of ionic bond. But in competitive examinations, we consider on this point. An ionic bond is formed between two atoms which differ much in electronegativities. If they differ more in the electronegativities, then only. How much they have to differ means at least 1.9. The electronegativity difference between the two atoms should be at least 1.9. Then only they will form ionic bond. Okay. So the base definition of the ionic bond is what? The oppositely charged ions are held together by electrostatic force of attraction. The bond formed is an ionic bond. An ionic bond is formed between the two atoms which differ much in their electronegativities. Okay, which differ much in their electronegativities. Then only it is possible. Okay, and already we had in the first video we had a clear-cut discussion regarding whenever a bond is formed, there will be decrease in the energy. Is it or not? So here also the same. When ionic bond is formed, there will be a decrease in the energy. Is it clear? And the most important, some more points I want to bring to your discussion, that is ionic bond is a non-directional bond. That is the most important point. Ionic bond is non-directional. Ionic bond is non-directional. First point, this is most important. Ionic bond is a non-directional bond. And the second point is ionic compounds do not have molecular formula. They have only empirical formulas. Okay? Ionic compounds do not have molecular formula. They have only empirical formulas. Okay? They have only empirical formula. They don't have the molecular formulas. That is most important here. So these are the basic fundamentals regarding the ionic bond, which when we enter into depth you should know. And no bond is 100% ionic. No bond is 100% ionic. Why no bond is 100% ionic and everything, we will have a detailed discussion now. Okay? No bond is 100% ionic. So whatever we had the discussion, just for your sake I am showing it in a glance. First we had the definition of ionic bond. Next, in competitive level, if they ask the electronegativities between the two atoms should be at least 1.9. Okay, and no bond is 10% ionic, and ionic compounds do not have molecular formula. They have only empirical formulas, and ionic bond is non-directional one. Okay. Now we will be having a discussion of ionic bond. So let us take ionic bond means what? See, any atom tries to attain 8 electrons in its valency shell, then only it attains stability. This was the concept which Lewis has finalized. Okay, and according to the octet configuration, any atom tries to attain 8 electrons in the valency shell. Now, suppose sodium, if you take sodium atom, 11 electrons, 11 is the atomic number, so it has 11 electrons. 1s2, 2s2, 2p6 and 3s1, 2 comma 8 comma 1. So it is having the nearest element gas is what? Neon. It has to lose that 1 electron, then it can form the stable. Okay, so what happens? Sodium has to lose the electron and forms Na plus and 1 electron. And chlorine 17. So chlorine electronic configuration 1s2, 2s2, 2p6, 3s2 and 3p5. It is there. So it is nothing but 2 comma 8 comma 7 or neon 3s2 3p5. See, it needs one more electron to get in a gas configuration. 8 electrons in the valency shell it has to. So it needs 1 electron. So this 1 electron will be taken and it forms Cl minus. So the electrostatic force of attraction between the Na plus and the Cl minus will result in the formation of NaCl. This is about the ionic bonding. Now, what are the factors that favor the ionic bonding? See, by seeing this you can say very clearly what are the factors that favor the ionic bonding. First one, what? Cation. It depends upon the cation. It depends upon the anion also. Is it or not? It depends upon the cation, it depends upon the anion, and also on the lattice energy. Already we had a clear discussion what is a lattice energy. The amount of energy required during formation of one mole of a crystal lattice structure is called as its lattice energy. So these are the things what the thing. So for cation, so I will write it very clearly. Factors favoring ionic bond. What are the factors that favor the ionic bond? Means for cation formation, what is required? Low ionization energy. Low ionization energy should be there. Then cation formation is possible. See, we have to remove the electron. So for that we should not give more energy, no. Less, it has to come out immediately. See, immediately it can come out. So low ionization energy is required for the formation of cation. Then it forms easily the ionic bond. Suppose first one is for cation, it should the cation which is formed that should have low ionization energy. And second one for anion, it should have high electron affinity. Means it should have the capacity to attract the electron. Okay, that we call it as electronegativity. But electron affinity means what? The amount of energy released when an electron is added. See, we are adding one electron to the chlorine, so it gives some energy. And that that should be of high, okay, high electron affinity, okay. Then what happens? There will be decrease in the total energy, then bond formation will be there. And the third one is what? For ionic compounds, high lattice energy one. The compounds which has high lattice energy, they are stable, okay. For ionic compounds, high lattice energy is required. High lattice energy will be stable, okay. If they have high lattice energy, they will be stable. That is the thing. And this lattice energy mainly again depends upon what? Again on the size of the cation and on the size of the ions and the distance between them, okay. So it depends upon the size. How? If high lattice energy should be there. High lattice energy is possible when the size of the ion is less, okay. Smaller the size, okay, smaller size of ions. Smaller size of ions will favor the high lattice energy, and the larger charge on the ions will also favor the larger charge on ions will favor the lattice energy. So these are the factors which favor the ionic bonding. So how the ionic bonding will be formed means where cation should be there and anion should be there. And how these anion and cation are formed? The element, the atom should have low ionization energy. Suppose if simply like this the question may come. An element is there, it has low ionization energy, and there is another element which has high electron affinity. So which type of bond they will form? So high electron affinity and low ionization energy means they will form cation and anion. So they can form ionic bonding. Suppose smaller ions, you see here Na plus and Cl minus. This is of atomic number 11 and 17. There is a large gap between them. 8 elements are there. So they will form stronger bonds. Okay? So they will form stronger bonds. That is also important. They will form stronger bonds. Is it clear? If the size of the cation and the anion is very large, then they will form the stronger bonds. Smaller size of the ions will favor the lattice energy, and larger charge will also favor the lattice energy. So these are the things what we have. Okay. The next point is what we want to discuss, factors theory. And there is another one which we have left. That is what? Electronegativity difference should be at least 1.9. Then only they can form the ionic bond. So the two elements, okay, the two elements forming the ionic bond, the two elements forming the ionic bond should have, okay, should have electronegativity difference of at least 1.9. Then they can form the ionic bond. More the electronegativity, okay, more the strength of the bond. Okay, electronegativity difference, if it is more, then the bond is stronger bond. Electronegativity difference is directly proportional to strength of the bond. directly proportional to strength of the bond. Okay, electronegativity difference is directly proportional to strength of the bond. Okay, if the difference is more, let us consider the electronegativity difference in NaCl is 1.9 and the electronegativity difference in MgCl2 is some 2.5. Which one is more stronger ionic bond means MgCl2. So why? More the electronegativity difference, more the strength of the bond. Okay, electronegativity strength difference, electronegativity strength is directly proportional to the ionic bond. Okay, and lattice energy. So here you are saying the small size of the ions and large charge of the ions. How the lattice energy will be? If there are two ions, cation, there will be repulsion. Anion, there will be repulsion. Cation, there will be attraction. Then how the lattice energy will be? Means the one which is having both ions greater than the one which is having both uni ions. Okay, bivalent. See, lattice energy orders I am writing. Bivalent. Bivalent ions is greater than bi-uni or uni-bi. Okay, uni-bivalent ions. It is greater than uni-uni. This is also important. Lattice energy of bivalent ions is greater than the bivalent univalent ions. See, example, suppose if you take Mg2 plus and Na plus, sir, which has more lattice energy. Bivalent ions is greater than the univalent. Means Mg2 plus is greater than Na plus. Okay, lattice energies bivalent. This is the concept. So what are the major points we can get from this concept is, first, in ionic bond, if it has to form, means what is the major condition? The two electronegativity differences should be more than 1.9 or at least 1.9. If it is more, means strong bond. Okay, electronegativity differences is directly proportional to the strength of the bond. Next, what are the factors that favor the ionic bonding? Means cation and anion formations. Suppose if there is a low ionization potential is required and high electron affinity is required, then the bond formation will be ionic bonding only. This is the concept. And how lattice energy will be influencing means smaller size of ions will have high lattice energy and larger charge on the ions will also have high lattice energy. And the compounds which are having high lattice energy always are ionic compounds only. And suppose how the lattice energy between the two same kind of ions means, if they are both bivalent, then their lattice energy will be greater than, it is the greatest. Bivalent is greater than bi-uni and it is greater than uni-uni. Okay, now we all know that ionic compounds, okay, regarding the ionic compounds, they are highly soluble in polar solvents only. Ionic compounds are highly soluble in polar solvents only. Okay, see, regarding the solubility, we will have a discussion clearly again. Solubility factor will have so many things again. Okay, so ionic compounds are highly soluble in polar solvents, we are saying. That is the major thing. Why they are highly soluble in polar solvents means because they have high dielectric constants. Okay, because they have high dielectric constant values. That is the major reason. And next, ionic compounds are having melting and boiling points high with the increase of lattice energy. If lattice energy increases, then melting point and boiling point of ionic compounds also increases. Okay, lattice energy is that. Okay, with the increase of lattice energy, what will happen? Melting and boiling points of the ionic compounds will also increase. That is the concept. And the solubility of the compounds will decrease in water. Solubility of the compounds decrease in water. So for solubility decrease or increase, first of all they should depend upon hydration energy. If hydration energy, okay, if hydration energy is greater than lattice energy, okay, if hydration energy is greater than the lattice energy, then it is soluble. I can write like this: for solubility, hydration energy should be greater than lattice energy. Then the compound will be soluble. What is hydration energy? The amount of energy released when a compound is dissolved in water. That is called as hydration energy. Okay? And next what we have, that is dissociation of most of the ionic compounds is endothermic. Dissociation, generally we can use the word dissolution. Okay? Why ionic compounds are mixed again with solvents? No. So the dissolution of most of the ionic compounds, okay, dissolution of most of the ionic compounds in water is endothermic. This is also an important point. Dissolution of most of the ionic compounds is endothermic. Okay. So for solubility, hydration energy will be greater than lattice energy. Suppose if hydration energy is less than lattice energy, means what will happen? The dissolution will be positive. Okay, the solubility will be positive. If the energy of the solubility is positive, means it implies, what does it implies? The hydration energy hydration energy is less than lattice energy. Lattice energy. Okay, the change in hydration energy is less than change. We can write the word change. Change in the hydration energy is less than change in lattice energy. That is, delta H solubility will be positive. Okay, so when delta H solubility is positive, then we call it is the thing. And sir, why lattice energy is used? Just we said that to estimate the stability of the ionic component. Stability of ionic component can be determined by lattice energy values. More the lattice energy, more stable. Okay, so more the lattice energy, more stable. And I think I have said to you in the class, Born-Haber cycle. Okay, the energy changes that are taking place in an ionic compound can be explained by Born-Haber cycle. Okay, and thus the lattice energy can be calculated. Okay, the energy changes, taking place in a ionic compound, in an ionic compound formation. Ionic compound formation can be shown by Born-Haber cycle. Okay, Born-Haber cycle, and thus lattice energy can be calculated. See, the energy changes taking place in an ionic compound formation can be shown by Born-Haber cycle, and Born-Haber cycle will help in calculating the lattice energy. Why we need lattice energy? To find the stability. High lattice energy values will give the more stable compounds. That is the reason. Okay. And what are the previous points we have? No bond is cent % ionic. That is the most important thing. Okay. And we will be having a small discussion at the end of the class, that is regarding polarization. Okay, polarization. Why this polarization comes means, and the starting I said that there is no cent % ionic bond, no. So this cation and anion are having electrostatic force of attraction, no doubt in it. So what happens means, this cation and anion will approach each other, and the nucleus of the cation tries to distort the structure. So this distortion will create some change in the shape, and that we call it as polarizing power or polarization. Okay, so what we will understand very clearly, no problem. So this is about the ionic compounds. Majorly ionic compounds, once again I am repeating, see, no bond is 10% ionic first, and what are, if a ionic bond has to form means the electronegativity differences should be at least 1.9, and ionic bond is a non-directional one, and lattice energy should be more. If more lattice energy is there, then it is a stable ionic compound. Okay. Next, what? If there is a large difference in their electronegativities, that also will decide the strength of the ionic bond. If they are having more differences, more stronger will be the bond. Is it or not? Next, smaller the size of the ion, larger the lattice energy, and greater the charge on the ion, larger the lattice energy. So these are the points regarding the ionic bonding. Next, we will have some factors. Okay. What is that? Lesser ionization energy will tend for cation formation, I said. How that we will see. Ionization rings. Okay. Generally, Na plus is greater than Mg2 plus is greater than Al3 plus. Is it or not? Okay. Less ionization energy. We are saying greater the tendency to form. Next, if all are there, then how? Cesium plus is greater than rubidium plus is greater than K plus is greater than Na plus is greater than Li plus. You see, I have written this order of cations. Okay, cation formation tendency. This is nothing but cation formation tendency. It depends upon what? It depends upon ionization energy. Already we have the thing. Low ionization energy will give higher tendency of formation of cations. See, this is period wise. Sodium, magnesium, aluminium, period. Top to bottom. So, what are lithium, sodium, potassium, rubidium, cesium, francium. So, these are what? Period. And this is a what? Group. See, in a group as we move from left to right, what happens to the cation means greater. In a period when we move from top to bottom, less, least. So this will become highest tendency. Okay. Cesium is having more tendency to form cation. Why? It can lose very easily when compared to lithium. More energy is required here, but here less energy is required, but here more energy is required. See, cation formation tendency, we call this order, which can form very easily cation means out of sodium, magnesium and aluminium. Sodium can lose one electron very easily when compared to Mg2 plus and Al3 plus ions. In a period which can lose easily electron means the last element of the period, that particular group, it can lose the element very easily, electron very easily. Cesium, rubidium, potassium, sodium and lithium. So this is the way we will be having cation formation. In the same way, anion formation tendency also we will look into that. Anions, chlorine, fluorine, bromine and iodine. Okay. What we said, high electron affinity will result in the formation of greater tendency of anions. Higher the electron affinity, higher will be the anion formation. So, chlorine, Cl minus, F minus, Br minus and I minus. This is in the period. In the group, this is in the group. And in the period, what we can write? What is the period we have? Nitrogen, oxygen, fluorine in the period. Okay, so fluorine is greater than oxygen is greater than nitrogen. So this is the formation, anion formation tendency. Anion formation tendency. We call them as anion formation tendencies. See, anion formation tendency. If you move in a group from a top to bottom, chlorine, fluorine, bromine and iodine. Okay, actually fluorine, chlorine, bromine and iodine, that is the element. But here chlorine is the most electronegative, electropositive element. Okay, so chlorine greater than fluorine, greater than bromine, greater than iodine. So anion formation tendency, which can attract. Whereas here F minus, O2 minus and N3 minus. So these are the things regarding the ionic bonding totally. Okay. Tendency of first we had a discussion regarding ionic bond factors favoring. In that cation formation favoring and anion formation favoring. This is the order. Here from this area we can expect the bits. Now we will be discussing about the factors that affect the solubility. Okay? Factors affecting the solubility of ionic compounds. Factors affecting solubility of ionic compounds. Why ionic compounds are only soluble in polar solvents? Why not in non-polar solvents? That we will get the answer here. First one is dielectric constant. The factor that influences the ionic bond is dielectric constant. And second one is size of the ion. And the third one is polarization of the ion. Okay? Polarization of ion. So these are the factors that affect the solubility of the ionic compound. Solubility of the ionic compound is affected by the dielectric constant, size of the ion and polarization of the ion. So what is dielectric constant? The capacity of a solvent to neutralize the charge of the ionic compounds is called as dielectric constant. Okay? What is dielectric constant? The capacity to neutralize the ions. Okay? The capacity of the solvent to neutralize the ions is called as the dielectric constant. Once again I am repeating, see the definition. The capacity of a solvent to neutralize the charge of ionic compounds. Okay, to neutralize the charge of, direct we will write neutralize the charge. Okay, neutralize the charge of ionic compounds is called as dielectric constant, and it is represented by epsilon. It is represented by epsilon. And water has the highest dielectric constant. Water has the highest dielectric constant. It is nearly about 80. Water is having highest dielectric constant. It is nearly about 80. Okay. And H2SO4 and H2O2. Okay, H2SO4 and H2O2 have high dielectric constants only. High dielectric constants. But they don't dissolve compounds. What is the reason? Means they undergo oxidizing. process. They are easily oxidizing in nature. Okay? But they are not good solvents. They are not good solvents due to their oxidizing nature. They will form other compounds. So that's why they are, you can say it's the dielectric constant of H2SO4 and H2O is next to water only. No? Why compounds are not soluble in that means they are not good solvents. Why? Due to their oxidizing nature. Okay, water is the very good solvent. Why? Means its dielectric constant is highest, and generally the order of dielectric constants, you can see here, dielectric constants for regular elements. Water is greater than methyl alcohol, and methyl alcohol is greater than ethyl alcohol, and ethyl alcohol is greater than acetone, and acetone is greater than ether. Ether is greater than benzene. So in competitive exams you can get this bit. What is the order of the dielectric constants? We all know that water has the highest dielectric constant. Next to water, alcohol. In this, the one which is having less hydrogens, that has more. You can see the formula H2O. Methyl alcohols. What is the CH3OH? Ethyl alcohol C2H5. That is CH3CH2OH. And acetone CH3COCH3. Ether CH3OCH3. Benzene C6H6. If you can see very clearly, here the oxygen is 1, here also 1, here also 1, here also 1. All means what? Oxygen is not going to decide the dielectric constant. Which is going to decide the dielectric constant? Hydrogen. If only hydrogen is there, that is the highest. Here what? Carbon is there. So only one carbon, but here two carbons are there. Here three carbons are there. Here again two carbons are there, but hydrogens are balanced, 6. Here 6 carbons and 6 hydrogens balanced. So that is the order. Order of dielectric constants. Water greater than methyl alcohol, greater than ethyl alcohol, acetone, ether and benzene. Which has the least dielectric constant means benzene has the least dielectric constant. That's why ionic compounds are dissolved in polar solvents, water like. Okay, that is the main reason. Next, what we have, size of the ion. How the size of the ion will be? Size of the ion depends upon what? Lattice energy. Again, higher lattice energy. It depends upon the lattice energy. And how the solubility means? Solubility is inversely related to the lattice energy. I can write here, solubility is inversely related to lattice energy. So more lattice energy, the solubility will be the least. Okay, so ionic compounds have highest lattice energy. That's why ionic compounds are not that much sparingly soluble in water. Okay, so that is the thing. Lattice energy decreases. Okay, solubility. Okay, when we discuss about solubility, solubility is inversely related to the lattice energy. More the lattice energy, least will be the solubility. And you can see 7th group elements formation with the first group, that is lithium halides. Okay, lithium fluoride, lithium iodide is soluble in water. This is the special case. Lithium iodide is soluble in water. Okay, lithium iodide is sparingly soluble in water. And the order you see, lithium fluoride is less than lithium chloride is less than lithium bromide is less than lithium iodide. Lithium fluoride is less than lithium chloride is less than lithium bromide is less than lithium iodide. This is the order of solubilities. The order of solubilities you can see. Okay, lithium iodide Li. Okay, so this is Li. Lithium iodide is soluble in water. So the solubility order, lithium fluoride is less than lithium chloride is less than lithium bromide is less than lithium iodide. Lattice energy decreases with increase of anionic radius. Lattice energy decreases with lattice energy decreases with increase of anionic radius. This, okay, lattice energy decreases with increase of ionic radius. Lithium fluoride, iodine is having more radius, so it decreases. That is the case. Okay, lattice energy decreases with increase of ionic radius. So lithium fluoride is less than lithium chloride is less than lithium bromide is less than lithium iodide. Okay, so regarding this is the solubility, and the reverse happens for the lattice energy. So Li is soluble in water. Among NaCl, MgCl2 and AlCl3, which is more soluble? Solubility of NaCl is greater than MgCl2 is greater than AlCl3. This is regarding the solubility. NaCl is greater than MgCl2 is greater than AlCl3. Solubility decreases in a period. Okay, you can write here solubility decreases in a period. Solubility decreases in a period. When you move, what happens? Solubility will be decreasing. That is the case. And next, last and final one, that is polarization. Okay, what is polarization? The same. There will be some attractive force between the cation and anion, but what happens? The cation distorts, then it creates a polarizing. In tomorrow's class, we will be having about the polarizing factor and everything. Fazan's rule will be there to explain about the polarization ions and everything. So now, solubility is inversely related to polarization. That one you note down. Solubility is inversely related to polarization. Solubility is inversely related to polarization. Okay, solubility is inversely related to polarization. That one you note down. Okay, solubility is inversely related to polarization. So regarding the polarization and everything, we will see in the next class. So this is all about the ionic compounds. Regarding their solubility, what are the factors that affect the solubility, we have seen. And in tomorrow's class, we will be having a discussion. The next video you will be getting regarding the covalencies, covalent bonding. These topics we will be discussing. Okay, and after that we will be entering into the details of sigma bond, pi bond. Okay,